Welcome everyone to our Tech Excellence Meetup. Our vision is to raise the bar of technical excellence across the world. The following are our organizers, Daniel, Oliver, Alina, and myself. And these are some speakers that we had, as well as upcoming speakers. And feel free to join our meetup group, subscribe to us on YouTube, and follow us on LinkedIn and Twitter. You can also ask any questions if you wish on Discord. So thanks to our sponsors Optivum and our partner QE Unit. So for today, we are really excited that we are being joined by Chris Holland, Vice President of Software Development at A Certain Path, who will be speaking to us about how to ship better software faster and have fun doing it. So thanks, Chris. And now I'll share the screen. So thanks, and over to you.
All right. Thanks for having me. So on your screen, you'll see two links. The one at the top, it's a bit.ly URL. If you type that in your web browser, you can download the entire PDF of this presentation. So in this presentation, you're going to see a lot of diagrams and some words that are underlined, and usually it's because I have links to some other places. So you can have literally everything at your fingertips by just going to this bit.ly, download the PDF to your computer or your phone, and then you have all this material. So you don't have to, if you miss something, you don't have to worry. It'll be right there at your fingertips. And then at the bottom, that's me on Twitter. If you want to say hi, that'd be awesome. All right, so let's dive into it. So we'll try to answer a few questions. What makes software not fun? Where does it hurt us? And can we make it fun? And to answer those questions, we're going to go through an agenda. And the agenda will look like this. The punchline of this presentation is going to be that test-driven development it's going to be the key enabler for all of this. And we're going to spend most of our time in this presentation on talking about TDD. However, ahead of doing test-driven development, we're going to talk a little bit about web application architectures, because as Valentina has brought up in the past, things like the hexagonal architecture can really help you be more effective at test-driving code. So we'll explore that. And before even getting to web application architectures, we're going to look at actually making the most out of object-oriented programming if we're going to use OOP as a paradigm. And then ahead of that, we're going to look at sort of the broader enablers of better code. But first, what we're going to start with is what I call bad code versus fun. We're going to explore sort of the impact that our bad code has had in taking away our fun. So as you may have all experienced when working on some code, it's rarely fun to inherit somebody else's code, and sometimes that somebody else is us from 2 weeks ago. Having a hard time understanding how a system works, that's always a challenge. Breaking old things when building new things, testing our work as much as we ought to. These are all sort of struggles that we face that make our job not as fun as it should be. And we've heard a lot over the years about agility. Every team out there says we want to be agile. And to do this, we have primarily focused on things like, project management and task planning, and that's kind of where Scrum and Kanban emerge as sort of effective management tools. We've also looked at CI/CD for managing what's called the integration hell, and then regardless of whatever technology stack we work with. We often work within some kind of MVC framework, and virtually every MVC framework that I've worked with claims to be an agile framework. That's by using it, it's going to make us agile. What I found though in my experience and in the teams that I've served is that regardless of what you see on your screen, there's always this underlying issue which looms and which kind of overshadows all of this, and it's the bad software that we end up writing. it almost doesn't matter if you're doing Scrum or Kanban, or if you have if you think you have a CI/CD pipeline, but you're still writing bad software. And so Martin Fowler kind of talked a little bit about that, and so he wrote an article called "Flaccid Scrum." I have a link to it here, so when you download the PDF, you can just click the link. You'll see his article. He puts it really well. It talks about the fact that teams embrace Scrum, but it becomes flaccid because they're not really paying too much attention as to how they write software. So we often end up in situations where we think that we are agile, but we're not. And what's happening is our bad software eviscerates just about every benefit of our agile stack. And if you look at it in terms of impact, if you look at a graph of new features released over time, like your ability to release new features over time, and on that graph, we're going to overlay sort of the technical debt that we accumulate. The very first thing that we're going to do is accumulate astronomical amounts of technical debt, which means that over time, this is what our graph of new features released over time looks like. At the top left, when we start the project, we release a lot of new features, and then as the project matures and becomes more complex and time passes, we find ourselves less and less able to release new features at a sustained pace. And so in this pink zone here, that's when we're very much not agile, right? If we are truly agile, it means that we are constantly able to respond to change in business, which most often means being able to pivot existing features, modify existing features, releasing new features. And so as time passes, we become less and less able to do that. And if you look at it in terms of business value, in the early days of your business, you have a pretty sharp increase in business value, but pretty quickly we plateau because our bad software starts to weigh us down. And we always come to a point where we identify a pivot that we want to do to stay in business, but we cannot do it because we fail to execute on this pivot because of the weight of our technical debt. And then at that point, that's kind of where our competition takes over. And for any of you who may have seen this movie, it's kind of this competition has this straw that reaches across the room and drinks your milkshake. So that was bad code versus fun. I wanted to kind of show a lot of the pain points that many of us have faced through our careers. Now I want to start looking at some broad enablers of better code. And so over the years, that's sort of working with different teams, we sort of identified sort of three main buckets of topics which tend to lead to better code. You got patterns, you got clean code, and you got test-driven development. If you're able to sort of wield all of this effectively, you can really have better software being developed. So TDD has been a key enabler for us, but we're going to come back to that toward the end of the presentation. Clean code. So you may have come across the clean code book from Uncle Bob, but there's a lot of adaptations for many languages. Here I have a link to a free adaptation by Peter Plenick on his GitHub. It's clean code principles applied to PHP. It's basically just object orientation, really. So it's you can really follow that and apply that to any stack. And then the other thing is patterns. So patterns are pretty impactful because in a way, when you leverage patterns, it really helps simplify the complexity of a system. There are a lot of patterns. The patterns that I am most familiar with tend to be object-oriented programming patterns. And so you got the Gang of Four book that you could read. If you work with PHP, you have like every object-oriented design pattern at this URL that is shown by example with like UML diagrams and unit tests and sample object-oriented code. So even if you work in C# or Java, this URL is actually pretty helpful in illustrating literally every design pattern out there. Object-oriented design pattern, that is. But if you like to operate using functional programming instead of object-oriented programming, there are also a number of patterns. So Scott Glashin, who has done a lot of work with F#, so he's written a number of articles on applying a number of patterns to functional programming. So I have a link to his main body of work here. But if you work with Java streams, there are a lot of functional patterns that you can apply there. If you want to learn more about functional programming, Anjana Vakil, she's got a great talk that does an introduction to functional programming. So I have a link to this here. So again, if you download the PDF for this presentation, you will have all those links, and you can just click on all those links and you read all those articles. But going back to object-oriented programming patterns, which is more my wheelhouse, these are some of the patterns that my teams and I have used, right? Like dependency injection, P0 through P3, P0 being like the most important, followed by P1, P2, and P3. Factory, command, repository, data mapper, strategy, decorator, adapter, wrapper, builder. These are some of the patterns that we have used pretty commonly in our applications. You may be using a lot of different other patterns, but I'm just kind of wanting to show you an example of what's been impactful for us. So, so this kind of concludes sort of the high-level enablers of better code. We're going to come back to some of these a little bit later on. I want to go back to focusing more on object-oriented programming, because I've seen a lot of teams use object-oriented constructs like a class, like an abstract class, like an interface, private, public, protected member variables and methods, but they're not really doing object-oriented programming because at its core, OP is about message passing between objects that know very little about each other. And in practice, what happens is not that. What often happens is I see a large system being built with object-oriented constructs like classes, and people build a component, start building a number of components that are tightly coupled, and then they build more components that are even more tightly coupled to those components, and keep doing a lot of that. And now you have a lot of classes that keep calling each other and know way too much about each other. And you end up with an extremely coupled system. You have tight couplings. And often what happens is if you need to change one thing in the system anywhere, you end up breaking everything most often. So if I am to take these challenges and turn them into goals, the goal is to arrive at a simple maintainable system made of loosely coupled components with a consistent dependency graph, and embracing design patterns is a good way to arrive there. And so when you do that, then you can arrive at a large system with a number of components that are not tightly coupled. They are loosely coupled, and now you can change one thing and break nothing, and design patterns for the win. And to me, this is sort of a big thing. Is sort of if you're really not leveraging patterns, if you're not organizing your object-oriented system according to patterns that make sense for your domain, you're really not doing object-oriented programming. If you have a bunch of classes that have a bunch of getters and setters everywhere, and they all call each other's getters and setters, you're really not doing object-oriented programming. You're just basically building coupled systems. So I really wanted to stress that because that's going to matter, as you start test driving things. All right, so that was for object-oriented programming. Now I want to dive a little bit into web application architectures. So I was very thrilled when Valentina started promoting hexagonal architecture in a number of her talks, because I think more people need to do this. I think it is important to recognize the importance, really, of being very intentional about how we architect our web applications. And for as long as I can remember, the default web architecture has been model view controller, MVC. And I understand the appeal of MVC. It makes a lot of sense. And the way I like to look at it is like its sweet spot is, are you building an application that's pretty much skinning your database? Are you going to have like CRUD operations for every table in your database? And if that's all you're building with no additional business logic, yeah, okay, that might be okay. It might be okay to do MVC. But in my experience, it paints me in a corner, because most applications may start out simple. Oh, I just want to do some basic CRUD operations. But eventually they always get more complex. And then there's no real layer for my business logic for what the domain of my business is. And so as we keep working with MVC frameworks, we often end up with a lot of framework coupling. And I sort of use this visual sort of Heineken pattern as a visual aid because I think of it as, here's my business. My business should not care about my framework, which MVC framework I'm using. My business doesn't care about controllers or whether or not I'm throwing JSON or HTML or CSVs to the end user. But when we work with most MVC frameworks and we are not intentional about our architecture, we end up with our framework being tightly coupled and tightly intertwined throughout the business logic, which makes the business logic very, very difficult to maintain. So instead, what I strive to achieve, and this is what you will see with sort of the hexagonal architecture concept. You'll see it in hexagonal architecture, but also the onion architecture. There's a lot of overlap between those two. Is having my business and then my framework being kind of this thin layer around my business, right? So I try to keep my framework at arm's length. And we're going to see sort of more concretely what that means. Another way to look at it is if I have my business, and then on one hand, I have my framework middleware, like my controllers, my views, and then my framework persistence, like my database, my ORM, things like that. Imagine having less coupling and just having a little bit more decoupling happening, right? And that's sort of my goal there. So how can we get there? And the solution is pretty simple: add more layers. So I'll show you an example. What I'm about to show you is sort of how we arrived at an architecture that embraces concepts of hexagonal architecture, but it's not the only way to do it. But so here's what we did. We still have controllers. In some cases, controllers may render some HTML views, but now in most cases, they actually would render RESTful API endpoints. In some cases, Google RPC and things like that. So we still have the controllers, but this purple zone at the top, I call it the connector zone. We keep it very thin. We might cover it with acceptance tests, limited use cases using either Codeception or Selenium. The point is, I don't want to cover all use cases at this layer because I want to be working at the layer below it, which is sort of this green zone that you see. So this green zone is what I call the domain zone, where you test drive everything. And in this domain zone, it is actually very easy and practical to keep 100% code coverage with the assumption that we do, in fact, test drive everything. So in this green zone, we'll have commands or queries which may delegate to service, delegates some work to services, which may delegate some data operations to repositories. All right, so if you look from the top left to the bottom right, you may have your controller at the top, which delegates. Your controller is very thin, and it delegates most of its work to one or more commands, which may delegate some work to services, which may delegate some data retrieval operations to repositories. And then you also have entities, value objects. So I have a link. You can see the words value objects being linked here. I have a link to an excellent presentation by Mijan Jovanovic. And he talks about leveraging value objects to deal with primitive obsession. I highly recommend this talk. And a big part of leveraging value objects is not only can you get rid of integers and strings, but you can also do a lot of data validation and data sanitation. And when something fails validation, you can actually throw exceptions. And that's one thing that I see that a lot of applications fail to do, is they fail to really create a lot of their own exceptions. I think it is very important, especially when you work in a language that supports typed exceptions like PHP, like Java, like C#. All three of these languages have a fully evolved explicit type system, and you can throw exceptions of a specific type, and you can catch exceptions of a specific type based on your object graph. So there's a lot of power and synergy between value objects and domain-specific exceptions. But also, you may also have DTOs in your application. So DTOs are pretty much just sort of data structures. So that's sort of the high-level architecture that we've embraced. And when you look at repositories at the bottom right, they allow us to do what's called polyglot persistence. So some parts of your application may be leveraging a relational database. Other parts of your application may be leveraging a document store or any kind of NoSQL database or key value store. It should be okay for an application to be working with more than one type of data store if you have the need for it. And the nice thing about this architecture and embracing the repository pattern is that it allows you to do just that. So that's sort of this architecture that's been very impactful for us. And everything that you see in the green zone, that's pretty much your business. Everything in the green zone is your business. It's your domain. It's your domain zone, and it does not care about your framework. It does not care about HTTP. It doesn't care about HTML or JSON or gRPC. All that stuff lives in the purple zone. That's just the connector stuff. So everything that's in the green zone is eminently testable, and you can very effectively test drive everything that is in the green zone. And that's, to me, what is the most impactful about this architecture. So what we looked at is essentially one possible way to achieve a hexagonal architecture. And I like to say that it's with a domain-driven flavor, because a lot of the patterns that you saw in the previous slide are actually part of domain-driven design. So that was web application architectures. So now that we have laid these foundations, that we have a better understanding of what clean code could look like, what object orientation could look like, what better application architectures can look like, now we can start diving into test-driven development where better fuels faster. So let's dive into it. The first thing that I want to look at is the why. Why would we want to do test-driven development? I think it is very important. I think every team, you never want to introduce a methodology just because it sounds cool. You have to ask yourselves as a team, what are our pain points and what are possible solutions to those pain points? And so I'm going to show you some of the pain points that my teams and I have encountered, and why and how TDD was a very effective way to overcome these pain points. So the first thing I like to ask is, what is software's greatest threat? And while you think of this, I'm going to take a sip. All right. So what is software's greatest threat? And before we answer this question, we're going to look, so keep this question in mind. What is software's greatest threat? Keep it in mind because we're going to answer it in a few slides. So first, let's look at a typical coding workflow. And it may seem familiar to you. So here's what a typical coding workflow could look like. I call it coding the hard way. So let's say I'm building my first feature. I'm going to write some code. I'm going to click the UI, or I'm going to pull up my HTTP client to stimulate the code, right, to test it. And then in the process, I might do some manual debugging to verify that the behavior that I'm expecting is actually what is happening in my system. I might run into some bugs, so I might fix some bugs in the process. And then once I have fixed some bugs, I'm going to click the UI again manually, or manually invoke my HTTP client to test my API endpoint. And then finally, I can stabilize feature 1. Okay. Now let's see what happens when we work on our second feature. So I'm working on my second feature. I start writing some code, and then I start, poking at it. Cool. And then, oh, I realized that I just broke feature 1. Oh, now I'm going to do some manual debugging such that I can fix the bugs that I just introduced in feature 1 while trying to build feature 2. And then once I think that I'm successful, I'm going to click the UI again to verify that I did succeed. And then finally, I'm going to complete feature 2. And then finally, I'm going to complete and stabilize both features 1 and 2. All right. Now let's introduce a third feature in this picture. You get the idea, right? So now I can actually break features 1 and or 2 in the process of building feature 3. And then I'm going to do some debugging, and then I'm going to fix the bugs that I may have introduced in features 1 and or 2. And then finally complete feature 3, and then finally stabilize features 1, 2, and 3. Already you can start picturing in your head sort of the overhead that we start adding with every new feature, right? With every new feature that we add, we risk breaking something old. So now when you do, if I'm to put this in a formula, features 1 through n, I can break features 1 through n-1, fix them, and then finally complete that one feature, and then finally stabilize all the features up to n. So that's sort of a high level of the overhead, right? And so now I want to give you sort of a visual representation of this overhead. So imagine at the top left, the effort to keep each feature stable. And at the bottom right, the number of features that we're adding in our system, right? And in my experience, the best case scenario, it's a sharp linear increase, meaning for every feature that I add to my system, my effort to keep each feature stable increases. And in my experience, it increases at the very least linearly in a very sharp way. But what I found is that it's actually worse than that. It's actually a lot worse. It's actually more of an exponential increase. With every feature that I add to my system, the effort to keep each feature stable increases exponentially. So looking at these pain points and going back to our question, what is software's greatest threat? And if you think about it, the answer is change. Change is software's greatest threat because each feature that we introduces change. And here's the problem with change. If I change something, I have to ask myself, did I break something? Right? I mean, that's always something that's in the back of our head. So let's do a little mental decision tree in our head, right? Did I break something? So I might test manually, realize that indeed I did break something, and then I debug manually, and then eventually I fix it. All right, cool. Now, I might be pressed for time, so I might not test, in which case, if I'm lucky, QA finds the bug, and I'm right back where I started. But then the situation can get worse. If QA doesn't find the bug, the customer finds the bug, and I'm right back where I'm started. So what you see on your screen is not very pleasant, right? Testing manually is a pain point. Debugging manually is a pain point. And to further verbalize those pain points, when dealing with change the hard way, I waited too long to test, so I have no idea when I introduced a bug, which leads to tedious debugging. And then testing is manual, it's time consuming, I hate testing, and as a result, testing is inconsistent, and then QA or the customer finds a bug before I do. So that's sort of a lot of what happens. So if I am to take these pain points that you see on your screen and turn them into goals, I'd like to be able to do early and constant testing, catch a bug right away, have an instant fix with very little to no debugging because I caught the bug right away. I like testing to be automated. I like it to be quick, instant, and I want to love it. And as a result, I want testing to be consistent with very few bugs caught by QA or the customer. All right, so these would be my goals. All right, so now that we've explored some pain points and then some goals, I'm going to ask you, where do we also waste time? And my answer to this is we waste a lot of time when stimulating our code. Stimulating just means I just wrote some code and I want to ask a very simple question. Does my code work? I have to stimulate it somehow, right? So let's look at how we do it traditionally in a traditional workflow. When we ask ourselves, does my code work? So here's my business logic. I have to interact with it. So I'm going to, at the very least, put some HTTP routes. I might scaffold a very basic user interface and then click the user interface. If I'm not doing user interface and I'm just doing an API, then I'm going to fire up an HTTP client to talk directly to the HTTP routes. Okay, I might do that. Another thing that we often do to stimulate our code is we'll put debug statements all over the place so that we can see what's going on, because sometimes we don't quite understand what is going on. We might use our IDE to step through code through the execution with a lot of breakpoints. And then we might also spend a lot of time visually inspecting our data store, right? Because in the end, web applications spend a lot of time moving data in and out of data stores. And so often the end result of a series of operations is to have modified the state of the data store. So one way that we verify that our code did what it's supposed to do is to sort of visually inspect the database. That's one way to do it. So Now let's look at a possible remedy. And all these pain points that we looked at, now we're going to look at where test-driven development can help us. And we're going to start where TDD can help us for stimulating our code. So I just showed you all these bubbles on the screen. So with TDD, all of these blue bubbles are going to go away. Boom. And what's going to happen is we're going to have a test harness around our business logic. And we will be able to tell that our business logic is doing what it is supposed to do through our unit tests. Okay. But it's really not about writing the tests after the fact. And so I'm going to show you now sort of what the TDD workflow looks like. So using the similar diagram that we did earlier to look at a traditional workflow, here's what a TDD workflow would look like for the first feature. So I'm building my first feature in a TDD workflow. So the first thing that I'm going to do is write a small test. Then I'm going to write just enough code to make the test pass. And then I'm going to run the test suite. Now, when I work on my next feature, feature is it's a loose term. It's like a incremental capability. It can be as small as you can possibly, think about it. So when you work on feature 2, you're doing the same thing. But as you run your test suite, you might find some bugs that you may have introduced, and that's fine. You fix the bugs, and then you run your test suite again. And then at the same time, you see this yellow refactor box at the center of the diagram. That's a great thing about test-driven development, is that we can actually improve the structure of our code with virtually no fear. Because if we improve our code and we break functionality, our test is going to tell us right away. So if you put all this together, that was for feature 2. Now I'm going to do feature 3. You can see that I'm not adding steps on the screen. You have the exact same number of boxes on the screen between features 1, 2, and 3. And here's feature 4. Again, you're doing the exact same thing. Features 1 through N, again, you're doing the exact same thing. You're not adding overhead when for every feature that you create. So now if I go back to this graph that we looked at earlier, for the effort to keep each feature stable over the number of features that we create, it's going to be more of a logarithmic increase, which is far better than linear or definitely exponential. So I'm not saying that as you add more features, my key point here is when you add more features to your system, yes, you're always going to have some overhead in making sure that your system is always stable. For one, it's a good idea to refactor your tests, right? To always refactor your code. But the nice thing is TDD makes that a lot easier. So your overhead is much lower to keep your system stable. So if I'm to summarize these concepts of test-driven development versus a typical workflow, we looked at a typical stimulation of our business logic that has a lot of overhead, and that's painful. Now with the TDD stimulation, all I'm doing is running tests. Okay. And then you had the typical coding workflow, right? Where every time I'm trying to add a new feature, I can break a bunch of things and I can never know exactly where I broke things. But in a TDD workflow, I'm not doing any of that. So we We looked at the overhead to keep each feature stable in a worst case scenario of a typical coding workflow. That was this exponential increase. In a TDD context, it's a logarithmic increase, right? So if I put the two graphs kind of superimposed, I would much rather be the green line than be the red line, right? And that's kind of what TDD, offers you. So going back to some of the concepts that we looked at earlier, we can look at some broader impacts of test-driven development. Your Agile stack without TDD kind of looked like that, right? Where you had sort of bad software, which overshadows all of your other Agile practices. But now that you actually embrace TDD, your Agile stack, because you are introducing TDD as part of your Agile stack, now you are in a better position to have better software at the center of everything that you do. So the first impact is you get an effective Agile stack. And then we looked at business value earlier without TDD, right? Where the competition takes over because you plateaued because you added too much technical debt. Well, the nice thing is with TDD, you can release features at a constant pace. So now you can constantly increase the business value of your business value, basically, right? So again, these are the two graphs superimposed. Would you rather be the red line or the green line? I would rather be the green line. So that's the second impact of TDD in my experience, is to really get a sustained growth of my business value. Now, I'm not saying that test-driven development is the only way to write better software, right? So we looked at these things earlier, right? TDD is one aspect of it, but you've also got patterns and clean code. So patterns, you have the solid principles, you have the Gang of Four design pattern, you have Martin Fowler's patterns of enterprise architecture, you get functional programming patterns, and then you got clean code as well, right? So, and we looked at clean code as well, and these things are very impactful, right? So if you can master patterns and clean code, you can do really well without doing any test-driven development. And a lot of teams I will say some teams are successful at this, and I think most teams can be successful at this up to a certain point. So let's say I am doing my best to embrace patterns and clean code, and I am not doing test-driven development at all, right? It's doable. The challenge, though, is that when you look at patterns tend to emerge over time. And also clean code tends to be an iterative process. And the problem is we fear changing code because, as we looked at earlier, anytime we change code, we risk breaking things. So we rarely improve our code, and our fear of changing code undermines improvements. And this fear of changing code is fear of improving code. And so the nice thing about TDD is it tends to remove this fear. And in fact, TDD is by and large improving code because it embraces refactoring at its core. So, and the nice thing about TDD is it's very easy to improve code, right? So let's say you're test driving a new system, and you're not thinking too much about patterns and clean code. You just want to get something to work. So you just test drive your code. You're not breaking things apart into classes or whatever. You're just, you're just getting a system to work, but you are test driving it though. And because you are test driving it, in the process of doing that, you start gaining a better understanding of what your system looks like, and you start identifying opportunities to refactor your code, to extract blobs of code into their own classes, for example, right? And progressively, you can have cleaner code and patterns emerge over time because you did test-driven development. So there are many other benefits of test-driven development. You can never fear changing code, improving code. The code is self-documenting. There's no silo of knowledge. You can spend less time clicking a UI to solve business problems, spend less time on tedious debugging, build new features more quickly, ship code more often, scale out development teams more effectively, build resilience to varying skill levels. All right. So we just looked at the why of TDD, and these have been our experiences, and I think your teams may have had similar experiences, but I think at least these arguments should provide a good starting point for your teams to ask yourselves questions and whenever you assess whether or not TDD is right for you. So now let's look at the how. There are a lot of really good tutorials out there on doing test-driven development. But most of them focus on simple algorithmic problems. They're actually algorithmically complex, but architecturally sort of simple. And the thing with web applications is they are the opposite of that. Web apps have several architectural layers. They should have many classes. And they are heavily data and IO driven. I mean, that's the reality of web applications. And if you go back to this architecture graph that we looked at earlier, virtually everything in the green zone is pretty easy to test drive. Commands, queries, services, your commands can mock the services can mock the repositories. Entities, value objects, and ETOs are very easy to test drive. But repositories, if you look at sort of the bottom right of the graph, repositories can get pretty challenging to test drive, because this is literally where you're doing your data operations. So how can you test drive repositories? And I think that's been the big missing portion in a lot of the TDD discussions out there, is how do I test drive data operations? All right, so I have a two-part answer for that. One is the flow for test driving a singular data operation could look like this. Let's say test, create, new thing. I might instantiate a new thing with some data in it. I might save it to my ORM through repository class. I might retrieve it by ID through repository class, and then verify that whatever I retrieved is the same as whatever I instantiated earlier. And then maybe verify that if I throw a bogus ID, then I can throw a relevant exception. So this is a diagram for an exercise that I put together to do a ride-hailing application. Let's say you're trying to build the web service layer for an application to request a car with a driver. So this is sort of what some of the use cases in the entity graph looks like. But at a high level, if a ride is to exist, at the very minimal, it's going to need a passenger and a departure. And then eventually, you might assign a destination and a driver to it. And if you look at what a passenger and a driver are really a user with a role of passenger or driver assigned to it. And then a departure and a destination are really a location. So if you look at this sort of as a tree, I start out by test driving the leaves of the tree, what's at the bottom of the tree, right? And so I'll test drive how to create a user with a role assigned to it. Then I'll test drive how to create a location. Then I'll test drive creating a ride with a departure and a passenger, right? Because the ride must exist with that. So that's going to be one test. And then I'll test drive how to assign a driver, and then how to assign a destination to it. So that's sort of a sequence of tests. But the point is, I'm sort of building my data graph incrementally in this process. So the second part of the answer is to do code first relational data design. And I explain what that is. First, let's look at a more traditional way to do data design. It's usually a database first workflow where I might create tables in my local database with columns. I'll create some foreign keys, set the primary keys, add indexes, and then I might tell my ORM to look at my database schema and automatically generate entities for me. And then once it has done that, then I'll start manually writing my repository logic, which I'm going to stimulate manually and then debug manually. And that's typically usually how we build things with an ORM. And obviously, my problem is with this red zone, right? Because this red zone here takes me back into manual stimulation, which is pretty much what we looked at earlier, right? So that's a challenge. Now, let's look at code first relational data design this time around. This time, instead of starting with a database, I'm actually going to start with a code. I'm going to create entities with properties where I'm going to put the proper annotations for the relations. I'm going to annotate my primary keys. I'm going to annotate my indexes. And then I'm going to ask my ORM to generate the schema. Usually my ORM can automatically generate a migration, which will generate the schema for me. And then I will still be manually creating my repository logic and then simulate it manually and then debug manually, and which puts us right back to this challenge that we had earlier, which is not great, but now because we did a code first workflow, we have the opportunity to sprinkle TDD on top of it like this. And now we can do a code first workflow with TDD. So if you look at this, you kind of make this go away. And now you can actually test drive your repository. And in the process of doing that, you're going to create your entities with annotations and primary keys and annotate indexes. And so when you do that, you're basically creating everything you need for your repository to work, and you're doing it inside of your test harness, which is the goal. So now you ask yourself, okay, that's cool, but how do I make my repositories work in my test harness? So I've done that with a couple stacks. But at a high level, if you look at your unit tests, and if you look at manual testing, and then you have your ORM at the top. So for my unit tests, I'm going to bootstrap my ORM against an in-memory database. And then for manual testing on my local laptop, yeah, I might just bootstrap my ORM against my SQL, right? It's just a configuration. So with PHP, it kind of looks like this. You're going to have a test harness with your ORM and an in-memory database, and then your unit tests, leveraging all that. So with PHP, I've done this with PHP Unit, the Doctrine ORM, and SQLite. In Java, I've done it with JUnit Hibernate, which implements the Java Persistence API, as well as HSQLDB. Now, I haven't done it in .NET yet. If somebody wants to collaborate with me on that, I'd be super excited to do it. But I know you can use the XUnit test harness. I've worked with Entity Framework in .NET. It's absolutely phenomenal. I love it. And then EF Core now has an in-memory database we should be able to leverage for this. So theoretically, it should be achievable there as well. So now if you ignore the UI, now that you've solved all these problems, it becomes very easy to test drive each layer, right? You can test drive your repositories, you can test drive your services, you can test drive your commands and your entities and your value objects. It should be very easy to do. So no matter what architectural layer you're working with, it's always this basic workflow instead of doing all of this. So all right, so the full stack workflow with the UI, you're test driving the business logic at the top left, and then in rapid iterations, And then you ask your ORM to generate your migrations from the entity graph, and then you can get to manual testing after having built your routes and your controllers. So this is another way to look at the workflow. You can build things independently. Again, you get your zone 1 and your zone 2, which do not need to depend on one another. So they're kind of decoupled. I have, if you want to see all this in action, I have many videos on my YouTube. So if you go to this bit.ly, TDD-vids, there's a lot of this. So I'm doing all this with Symfony 3.4. That was my last live demo that I did. So I need to update it, but I have all of this on my GitHub and on my YouTube channel. So, all right. If you want to do more reading, I recommend everything Sandy Metz has ever written. She is awesome. If you want to learn more about unit testing patterns, you have the Jar Mezaros book. You've got Martin Fowler's refactoring book. You got Michael Feather's legacy code book. So the key for me is it should not be about pitting better versus faster. For me, it's about better and faster, such that better software fuels agility, which means more fun, which keeps us in business. So we can do whole lot less of crawling through river of excrement and do a whole lot more of writing better software at the center of our Agile stack with sustained agility. So that's pretty much all I had. Again, you can download the slides at this bit.ly, and here's me on Twitter. I am done and open for questions now, Valentina.
Great, great. Thanks for that presentation. It was really useful to see the whole cycle, and also to see the connection, how we do need hexagonal architecture as the foundation, and also later seeing how we can apply TDD both for business logic but also for infrastructural aspects. So let's go through some of the questions from our audience. So the first one, why factory is more important than the builder?
I was just showing sort of the different patterns that we use based on frequency at the time that I put this slide together many years ago. So I'm not saying any of those patterns are more important than others. I was just saying I've used that more. So yeah.
Makes sense. You're just illustrating, okay, what in your project what was used more, but technically it's a whole other aspect of the debate. So it's not a statement of what's more or less important. They are both important.
Yeah, absolutely. It's, every team is going to find, different patterns, and it's all good. I think as long as you're trying to think of embracing wisdom, which has existed for decades, on how to organize your object-oriented system, I think it's good, right?
Exactly. I mean, both of them can be used for creation, so I guess it depends on the case which one is more appropriate.
Yeah.
Okay. Next comment. In my opinion, object-oriented programming is not a pattern. The overly using pattern is a familiar sign that O is not used right. Now, I'm not sure if that is clear to you, or if you could provide some.
Well, I think it sounds like an agreement. The point that I was trying to make is a lot of teams claim that they're doing object-oriented programming because they use classes and interface and abstract classes, but the way they are organizing their code, where they're not using any architecture, they have objects that know way too much about each other, and they're not using any kind of design patterns, then they're not really doing object-oriented programming, right? Like the essence of object-oriented programming is message passing between objects that know very little about each other, right?
So. Exactly. That's a good point, and it's something that I've observed even in languages. I mean, in Java, which are seen as object-oriented languages, but yet people are programming in Java almost as if it's like C or something else. As in, for example, when people aren't using encapsulation, so just having getters and setters everywhere, and no encapsulation of behavior associated with the objects.
Yeah, for me, getters and setters are tend to be a pretty big smell for me. Like sometimes I can't get around from having it because I'm working with entities in ORM and then need it or whatever. Okay, but usually when I see classes with a lot of getters and setters, I always ask why, right? Because then it means that you have another class interacting with those getters and setters, which means that that other class is affecting business logic, which should belong to the first class in the first place. So yeah.
Exactly. How about, I don't know, Oliver and Alina, maybe you want to share your experience as well regarding this point?
Yeah, me in general, I'm very, very happy you brought up this whole OP topic, because I've seen Java projects like functional Java or procedural Java, and still we tried having discussions about hexagonal architecture, for example. So it was quite tough. So I'm very happy you brought up this topic together with hexagonal and TDD.
And it's interesting because it gets into the technology stacks, right? Like I've had a lot of people say, well, Java is an object-oriented language. And I'm like, okay. And people say, well, you know, PHP is not an object-oriented language. I'm like, actually, PHP fully supports all the key object-oriented programming constructs you would care about, right? PHP has class, abstract class, interface, private, public, protected, member variables, and methods, and it also supports explicit types. In PHP, they call it type hints, and they're actually optional. But when you actually specify those what they call type hints, they're actually explicit types. They actually act as a contract, right? So if you try to pass a duck to a method expecting a goose, then you're going to get a very loud error message that tells you exactly what you did, right? And so, so to me, OP is really, as long as your language supports some key things, you should be able to do good object orientation in any language, and you should be able to bad object orientation in any language, right? To your point, just because an application was written in Java or C# and .NET, you know, which are both phenomenal stacks and ecosystems, you can still, and people do, write absolutely horrendous code in Java and C# and .NET, just like they do as well in PHP. But at the same time, there's a lot of people writing beautiful code in all three of those languages. So the point that I try to make is like, the stack is never the problem or the solution. It's really what we do with it.
Yeah, and I just think probably the problem is also the name design pattern. As soon as you come up with design pattern, everybody is going to think about the Gang of Four design patterns. And they have their place, especially when you develop a framework. But the problem is when you are straight out of university or so, usually what happens is you apply your Gang of Four patterns in the first project you are in, and well, it usually doesn't result in maintainable code. And that sometimes leads to also very unmaintainable bad code as well, as even if you mean similarly to if you didn't actually apply any patterns. So maybe that could be a reason too, for me at least.
Yeah, and I think, you know, if you look at the Gang of Four design patterns, I see them more as sort of micro patterns. Like if you haven't sort of address which broader macro architectural patterns you're going to embrace and how you're going to organize your business domain, like you really need to do that first, right? And then once you've done that, then yeah, if you see an opportunity to apply a design pattern, then okay, it makes sense. I've come across that as well.
So basically, the separation of concern is much more important, so that you say, well, that's business, that's presentation, that's data access, than how you actually structure it in between.
Right.
Yes, we could say, I mean, sort of like high-level patterns, I mean, the architectural patterns versus those lower-level patterns which tell us how to organize the objects themselves. Okay, so this was good discussion. Now, next point, I think it's related to the above. Be careful not to use terms like domain to refer to smells that don't really have to do with domain, but with object responsibilities. So I think that this is related to this discussion. For example, when we have classes that don't have clear split of responsibilities, but are, for example, interfering with each other, and this problem is independent of domain modeling. It exists even outside of domain-driven design. I think maybe that's what this was about.
Okay.
Okay, next point. This is not really talking about frameworks, but creating abstraction layers in order to have a safe testing strategy that allows us to use dependency inversion correctly. And then I also added, exactly, abstracting away frameworks. So maybe we could comment a bit about that.
Yeah, I think it's I mean, that kind of goes back to one of my earlier slides where
Okay, I'll show your screen now.
Sorry, I just okay. Get back. No. Goodness.
I think it was the part where it was hexagonal architecture.
Yeah. Sorry, I just got.
Where there was that slide.
Yeah, here you go.
You had connectors and that one.
Yeah. So that was the point of this slide, right? Your framework, for the most part, lives in this purple zone at the top. All right, and so I try to keep everything that's in the purple zone as thin as possible, and I try to keep everything sort of in the green zone, and for the most part, all the stuff in the green zone is framework agnostic, pretty much. Right. So.
Exactly. So that's essentially creating, how shall I say, there's like a layer of abstraction. I mean, for example, repositories are an abstraction over databases. Okay. Great. So thanks for that. I'll now go back to the questions. So test first. This is the way. So yeah, this was quite useful how you showed to us. I mean, the usefulness of test-driven development and test last. Maybe you could. How would you formulate the shortest possible argument for why someone should be using test-driven development versus test last?
Sure. Responding to change, really. People talk a lot about being agile, and the essence of agility is really being able to respond to change. And so if you are in business, you are going to face change in business, and that's going to directly translate into your software. Okay, like you have to embrace change in your software. You have to be able to not be scared of it. And in my experience, test-driven development is the most effective way to embrace change.
That's a nice summary, and I guess that could be linked to maintenance cost as well. So yeah, this was pretty good that we covered these questions. So maybe Oliver and Alina, feel free.
So my first question is actually, I mean, we advocate now for TDD, but I guess you have seen also like teams that, although they did TDD, they may have started too early with refactoring and then ended up with bad abstractions, or they had to, every time they tried to refactor something, they had to change the test as well. Did you experience stuff like that too, or?
Yes. So the biggest thing that you need to be careful with when it comes to your tests is duplication in your test code, right? So anytime you create a test, you're going to set some things up. You know, you have like given, when, then. When you start creating more tests, you're going to start duplicating a lot of code in the way you set things up, and even the way you stimulate your. You should look. If you look at your production code and you look at your test code, you should look at a production code method and see that it's not being referenced by more than one place in your in your test code. So Uncle Bob actually had an article about that. He called it creating an API between your tests and your production code. API as in not a network API, API as in an application programming interface. Yeah, I'm trying to.
Yes, that's a very okay. Do you want me to share your screen again?
Yeah, he has. Yeah, I'm trying to. Hold on. I'm trying to find.
Yes, I remember that one as well.
Anyway, we'll take it offline. See if we can find the article that he had. But he had this diagram where he kind of showed tests calling production code and kind of having an API in the middle, so that if you change something about your implementation, you only have to change one place in your test.
It's a good article. I copy pasted the link below. It's called TDD Harms Architecture, which is one that I had also referenced before. So what he's talking about, I think it's relevant to go with the whole audience, is initially he was writing tests per class. And then what he noticed was that essentially those kind of tests became fragile, because as soon as he changed something about the class, all of those connected tests broke. So then what he did was, when we have tests on one side and production code on the other side, instead of like every test contacting each class, essentially having that very low level somehow coupling, he introduced an API in between, so that the tests are coupled to the API, which is of much less surface area, like much less surface area of coupling compared to being coupled to all the classes. And his use cases are the entry point to the application. So his use cases are effectively that API. So he's coupling the test to the use cases. It doesn't matter how many classes are behind the use case. He couples the test only to the use case.
Yeah, and Martin Fowler also talked about this in one of his articles. It's called sociable tests versus, I don't know, not sociable tests.
Solitary unit tests, yes. So we can say Bob is writing sociable unit tests, which are targeting the use cases.
Yeah, which is also the way I prefer to do it. So a lot of the folks on my teams were fans of, one test, one class, and we ended up doing a pretty okay job of keeping those tests maintainable. But I've also opened it up to them and said, you don't have to confine yourselves to this paradigm. Like in some cases, it makes sense to look beyond that. So
yeah, that is definitely a useful reading and investigation, and I myself also currently mainly use sociable unit tests, targeting the use cases. There are some cases when I go to lower level testing, but that for me is currently an exceptional case rather than the most common case is writing tests targeting the use cases. Okay.
So, but my question is a bit, isn't test-driven development more like the holy grail? I mean, if you have mastered basically everything, you do test-driven development. And you cannot just go to a junior, let's say junior team and say, let's do TDD. I would assume it goes wrong there. Or what is your experience?
Right. Well, and so that's kind of why I put this presentation together, right? Because there are a lot of topics leading up to that, to doing TDD, right? There's a lot of things, before that, and then you have to understand the why, and then be very intentional about the how. So yeah, no, it's not easy, and you got to be very intentional. And this presentation kind of helps you provide a guide toward that for sure. But yeah, it's definitely not trivial. Valentina, I kind of have to go in a meeting.
Yep, that's fine. So I just want to say thanks a lot for today. It was really great to hear about your experiences. So we'll be having links to your profile in the description below. And just to say thanks to everyone. So feel free to register on Meetup, and you can subscribe to us on YouTube and follow us on LinkedIn, Twitter, and GitHub. So thanks again, Chris, for the presentation, and have a good day. Bye.
Thank you.
Thank you.